This video will explain how to solve challenge question for exercise buffering and map overlay. You are given two shapefiles from an area around Imida, Idaho, for the purpose of locating potential habitats of Pacific U. For those of you who are interested what Pacific U is, these are the images. It's a tree that is native to the Pacific Northwest. Okay, so there are two shapefiles. One is elevzone shapefile. It shows elevation zones through the zone value. This is important to notice. One corresponds to the elevation lower than 3,000 feet. Zone 2 corresponds to the elevation between 3 and 4,000 feet. And zone 3 corresponds to the elevation higher than 4,000 feet. And another shapefile is LF-stream, which is the stream coverage. Both of them are measured in meters and spatially registered. It is very easy to set up map and display units in ArcMap. Once you added both shapefiles to the table of content, as I did here, you can right click on the map, go to data frame properties, and you will be able to set up under general map units as meters and display units as meters, and click OK. Okay, so to identify potential habitats of Pacific U, you must meet the following two criteria. The habitat is located between 3 and 4,000 feet in elevation and within 200 meters of streams. So these are two conditions are given to you. This task and tasks similar to this task represent so-called site selection problem in ArcGIS. So we will be selecting sites based on the provided criteria. Okay, so first of all, there are different ways how to approach this challenge. I will show you my own way. First of all, I would like to meet the second criterion and select areas within 200 meters of streams. For that, we will build a buffer within 200 meters of our streams. So we will use Arc Toolbox, and under proximity, we will use buffer. We will specify streams as our input feature. We will make sure that our output is stored in Ex7 data folder. This is very important. So I will make sure that my outputs all go into this folder. So I will give it a name, and you can come up with your own name for this output. I will call it st_buff. Okay, so and now it is in my Ex7 data folder. We will specify 200 meters as linear units, and I will use the dissolve type all, so my buffers will have dissolved boundaries, and I will click OK. So I will close my toolbox for now. So you can see that buffers are now built around streams within 200 meters. So the first step of the challenge question is complete. Now the second criterion is to locate areas between 3 and 4,000 feet in elevation. So our elevation shapefile represents elevation zones through the zone value. Okay, I wanted to look at the elevation attribute table. So this is my elevation shapefile attribute table, and you can see that there is zone column. So this is an attribute. So 1 represents elevation lower than 3,000 feet, 2 is between 3 and 4,000, and everything that is higher than 4,000 is identified by value 3. Okay, so if we create an SQL statement and say that zone is equal to, because we are looking for elevation between 3 and 4,000 feet, and that is our zone 2, and say apply, we will see that there are certain areas are highlighted in our shapefile, elif zone. So now, to simplify my process, I would like to export the selected areas as a shapefile. So I will go right-click elif zone, having my selected areas on the map. I will go data, export data. Only selected features will be exported, and my output will go to Ex7 database, and I will call it zone 2. Okay, and I will save that. Oh, it says that zone 2 exists already, so then I will just give it another name, zone 3. I've done this demonstration before, that's why I have zone 2 that I created already. But you can give it your own name, it doesn't matter how you name it. And save. Okay, so now I want to add this newly created shapefile to my map. Now it's colored in purple. I will change the color because I want to distinguish between the buffers and my elevation zone. Maybe I'll make it green. Okay, so now I have two outputs that I just created. One is buffer, another one is shapefile with elevation between 3 and 4,000 feet. And our habitat should meet both criteria simultaneously. So that means that I am looking for the areas where these two intersect. So I will use intersect tool under overlay toolbox, and I will intersect my zone 3 and my stream buff. I will save it in my Ex7, and I will call it habitat. Okay, and I will click OK. It will take a few seconds to process the intersect, and the new shapefile habitat is now added to the table of contents. I will change the color so we can clearly see it. So now all the pink areas are the areas of potential habitat for Pacific U. You can uncheck those other files so you can clearly see those areas. So we created two intermediate outputs and then we intersected them. But remember, we need to answer two questions here. First of all is how many records habitat has. You will answer that question. And the second, what is the total updated area of potential habitat of Pacific U? Right? So remember, to get the true areas in this process of site selection, you have to place this newly created file into personal geodatabase. So I will go to ARC catalog. I will navigate to my Ex7 connection. I will create a new personal geodatabase here, and I will call it U. Okay, so then I will right click on it. I will point to import feature class single, and I will import my habitat as a feature class into this new geodatabase, newly created geodatabase. Okay, so I will call my output habitat updated. Remember that you are not allowed to use dashes or anything except for underscores in file names when you work with GIS. And click OK. Okay, so now the process of conversion is completed now. And if you go to add data, you will see, if you double click your database, you will see habitat updated as a feature class here. Go ahead and add it to your data, to your map. So now it's colored in this gray color. So this is the file from which you will get your updated areas. Right click on it and open its attribute table, and you will see that there are two newly created columns, shape area, shape length, and shape area. So the question is, what is the total updated area of potential habitat? And as you remember, to get statistics, you right click at the heading of the column, point to statistics, and the sum is what you're looking for. So this is the number that is your total updated area of potential habitat of Pacific U. This is your solution for the challenge question.